Hello everyone. Today we are going to discuss about the topic photoelectric effect. This presentation is presented by Niti and Sargam from class 12th A. Photoelectric effect. The phenomena of ejection from a metal surface when light of sufficiently high frequency falls upon it is known as photoelectric effect. The electrons so emitted are called photoelectrons. Let us discuss about the Hertz observation regarding the photoelectric emission. The phenomena of photoelectric emission was discovered in 1887. It was discovered during the electromagnetic wave experiments. It was noted that high voltage sparks, which were actually the electrons across the detector loop, were enhanced when the emitter plate was illuminated by ultraviolet light from the arc lamp. It was also noted that when light falls on a metal surface, some electrons on the surface absorb energy from the incident radiations to overcome the force of attraction of ions from the metal surface. After gaining sufficient energy, they escape to the surroundings. Now let us discuss the Hallwach and Lenard's experiment. Lenard observed that when ultraviolet radiations were allowed to fall on the emitter plate of the evacuated glass tube enclosing two electrodes, current flows in the circuit. As soon as the ultraviolet radiations were stopped, the current flow also stopped. These observations indicate that when ultraviolet radiations fall on plate C, electrons are ejected from it, which are attracted towards the positive collector plate A by the electric field. The electrons flow through the evacuated glass tube, resulting the current flow. Thus, light falling on the surface of emitter falls current in the external circuit. Hallwach in 1888 connected a negatively charged zinc plate to an electroscope. He observed that zinc plate lost its charge when it was illuminated by ultraviolet light. Further, the zinc plate became positively charged. Positive charge on the positively charged zinc plate was found to be further enhanced when it was illuminated by ultraviolet lights. From these observations, he concluded that negatively charged particles were emitted from the zinc plate under the action of ultraviolet light. Now let us discuss about the Hallwach and Lenard's observation. Hallwach and Philip and Lenard investigated the phenomena of photoelectric emission in detail during 1886 to 1902. The observations were summarized as below. When light is incident on a metal plate, it may cause the electrons to come out of the metal. Hallwach and Lenard also observed that when light fell on emitter plate, no electrons were emitted at all when the frequency of the incident light was smaller than a certain minimum value. This frequency is called threshold frequency. It was also noticed that different metals have different threshold frequencies. Now let us discuss about the other results of Hallwach and Lenard's experiment. It was found that certain metals like zinc, cadmium, magnesium, etc. responded only to the ultraviolet light, having short wavelength to cause electron emission from the surface. Some alkali metals like lithium, sodium, potassium, cesium, and rubidium were sensitive even to the visible light. Experimental study of photoelectric effect. The apparatus required for the photoelectric effect experiment is as follows. Number 1. Evacuated glass tube fitted with two electrodes. Number 2. Electrode E is called the emitting electrode. Number 3. Other electrode C is called the collecting electrode. Number 4. A battery. Number 5. A micro emitter. Number 6. A glass window which is provided in the tube. The experiment. When light of suitable frequency is incident on the emitter through the glass window, the photoelectrons start emitting from the emitter. Since collector is kept at positive potential, the photoelectrons start reaching the collector. Thus, the electric current flows through the circuit called the photoelectric current. In this experiment, it is important for us to understand the effect of intensity on photoelectric current. Here, the collector is at positive potential and intensity is increased. Photoelectric current depends on the number of photoelectrons reaching the collector per second, that is, the intensity of light. As the intensity of light increases, photoelectric current also increases.
When light of same frequency but different intensities is made to incident on emitter, the graph shown is the result. We have different saturation current level, but for all the intensities, stopping potential is same, because intensity does not affect the energy of the emitted electron. If the light of same intensity but of different frequency is made to incident on the emitter, we get the graph as shown below. Here we have different values of stopping potential but the same point of saturation current. The graph between stopping potential and frequency does not pass through the origin. It shows that there is a minimum value of frequency called threshold frequency below which photoelectric emission is not possible, however high the intensity of incident light may be. It depends on the nature of the metal emitting photoelectrons. Here we'll go through the laws of photoelectric emission, which were summarized as experimental features and observations. Before that, we should know that photoelectric current depends on three factors. Number 1, intensity of incident light. Number 2, potential difference applied between the two electrodes. Number 3, the nature of emitter material. Here, through small experimental setup, we can observe that classical wave theory could not explain the main features of photoelectric effect. Therefore, even by increasing the intensity of the red light falling on the surface of metal, it did not emit any electron. Einstein's photoelectric equation is in accordance with the energy conservation law as applied to the photon absorption by an electron in the metal. The maximum kinetic energy, that is half mv square maximum, is equal to the photon energy, that is h nu, minus the work function phi naught, which is also equal to h nu naught of the target material. So, this was all about photoelectric effect. We can also demonstrate the effect on our own at home itself. Just follow the steps given below and observe for yourself. Thank you.